3D printing today, issue number 426. Printing PLA mixed with stainless steel. Cheap nozzles. Nimble fail.
Welcome back to 3D Printing Today, the podcast about all aspects of 3D printing. Hobby, professional, industrial, it doesn't matter. We cover it all. My name's Andy Cohen, and I'm here with Mr. Whitney Potter.
How you doing, Andy?
I'm doing pretty good. You see the story about Epson?
I did. Yeah, it's interesting.
Yeah, Epson's going to be joining the industrial 3D printing additive manufacturing market. And Epson, for those of you who don't know, because it's possible that you may not know this, but Epson was actually one of the biggest selling dot matrix and copy inkjet 3D, not 3D printing, but 2D printing.
Mm-hmm. Sure.
That in the old PC days, Epson was big. And they're still kind of big in the 2D printing world.
Yeah, in fact, I actually prefer Epsons to HPs because they're not quite as proprietary about their ink cartridge thing. So it's easier to use third-party ink. I have an Epson printer I use with dye sublimation ink that you can't do that on an HP printer because of the different technology. So Epson has a good following with the artists of the world, and I have actually two Epson EcoTank printers where instead of buying ink cartridges, you buy ink in the bottle, and I have yet to have to refill either of them, and I've had them both for years.
But that's 2D. I don't care. This is 3D
I don't care. It's 2D. Well, I'm just 3D
printing.
I'm just saying, Epson, they're good people.
Oh, well, I hope so for their market's sake. But it looks like they're now making a foray into the big name manufacturing market and competing with companies like Stratasys and 3D Systems and others out there. And they're coming in an interesting way, and which makes this an interesting story. And that's and this is an extrusion. I guess it is FDM. I guess it is FDM. Yep. And they're not going to use filament. Instead, they're going to go right to pellet. Direct to pellet.
And using the flat screw extrusion mechanism, which they don't show you a picture of it. I can't quite picture what that would be like.
They do show a photograph of the nozzle, which looks very different from what we've seen in the past.
It does, but it looks very much like an FDM printer, though.
Yes. Now, this is out of 3D printing industry, and 3D printing industry describes this pellet driving screw as something that's based on their 2D technology, which is interesting. That means that somehow they've got a patent on it. I don't see how that's possible, though.
Yeah, well, their 2D technology is extruding liquid.
Yeah, which is interesting.
on a micro scale. So,
and also, there's another aspect of the story which makes me wonder, because they state that the advantage here is that, you skip the process of having to extrude the pellets into a filament, which is a substantial savings. Mm-hmm. But that means that there's an assumption here that the Epson machine, you'll be able to buy the pellets straight from the pellet manufacturers, and that doesn't make sense. For the industrial markets, you usually have to be as deterministic as possible, which means you don't just sell the equipment, you sell how to operate the equipment.
And you sell the materials.
And the materials.
And the build plates and
everything.
All the other consumables,
Now, there's two reasons for that besides the fact that you got profit. There's a profit motive.
Right.
The only way you can ensure that the output is as deterministic as possible and within tight tolerances is to keep control of the entire thing.
Right.
Which makes me wonder, okay, you've got pellets, but that based on industrial manufacturing, that doesn't necessarily mean that you're going to be able to buy the pellets from the actual pellet makers.
Yeah. Well, it's an interesting question. If you're talking about, pellet-based printing tends to sort of lend itself to very large volume sort of production because you're into the realm where you care about the cost of the materials to the extent that you are wanting to save that money by, getting the pellets, directly. And so, it really doesn't make sense if you're going to be buying pellets from Epson But of course,
so it's kind of like, well, this doesn't make much sense.
Well, but assuming that you have the ability to tune things for a large production run, I mean, you end up buying, 100 kilograms of a pellet or something, and then gear up for the production run and tune it all in based on that batch, and you should be okay.
Yeah. No, they're not the only ones doing it. There's a bunch of others that they're mentioning in the article, but Epson's they've got street cred. And so good luck. We'll see what happens. In the meantime, we've got a show coming up. What's coming up on the show this week?
We do. Let's see. We start out talking about printing PLA mixed with stainless steel.
And then we get into a discussion of cheap nozzles, and I'm going to retract my opinion at the end of it.
Retract it already?
Right,
okay. Yeah. And then we talk about a nimble fail.
Okay, let's do it. So the other day I'm cleaning off my specialty filament shelf. In other words, spools of filament that I never use.
Yeah, I threw out a bunch of those not long ago.
Yeah, I mean, there's stuff up there like PLA PHA, I think it was called, and there's a couple of specialty artisanal HTPLAs up there, like the coffee infused one.
Oh yes, I have the algae infused one. I have the algae
can keep
one.
That one.
Yeah, I think I got rid of the algae infused one.
The coffee one prints really nicely and it smells just wonderful.
Oh, that's good.
Yeah, that's the stuff from Protopasta.
The algae one smelled kind of like a beach fire, and it lingered for days.
Well, Protopasta's a bunch of the spools that are up there, and these are spools of filament that I really like, but I don't want to just use. I want to use them for very special use cases, which means I never use them. And so one of them I found up there.
Save them till they go bad because they're that precious.
Right. And that's an important thing that you need to know is that PLA goes bad.
You bet.
And so I noticed, there's a couple spools of this PLA with stainless steel.
Right. Save it for when your day is going really well and you need some frustration thrown in.
Yes. So 2 spools, one from Protopasta and one from ColorFab. ColorFab's steel fill. Now, the spool from ColorFab was sent to me by MakerBot when I was testing one of their craptastic 3D printers a long time ago. Surprisingly, it did okay with this filament. It actually printed, but the stuff has flow issues. Now, I wanted to just use the stuff and have some fun using it and experiment with it. So I took both spools out to the garage and I did a print of an object, which is basically let me see if I can find it. It's a storage, it's a bolt. It looks like a bolt. There's a couple of them on Thingiverse. See if I can find it here. The secret box keychain or the bolt keychain.
Yep.
Let's see. The one I think I did was the secret box keychain, which is thing number 514-1454 by a user with the handle Claymore. And this object is basically, it looks like a bolt, and you can unscrew the threaded part out of the cap. And the threaded part of the bolt is empty, so you can
it's hollow. Yeah.
put little things in there clandestinely.
Oh, that's cute.
Aren't you being secretive? How well this will work on a keychain, I don't know, because the tab will just pop right off over time.
And you printed it in stainless steel, so you never have to worry about it rusting.
Well, maybe if it rusted, that would be a good thing. I don't know.
Yeah, no, it won't rust because it's stainless steel.
So I did the first print in the ColorFab steel fill. That's the stuff that MakerBot sent me, and so I admit it's on the old side. And I noticed during the load sequence where I kind of let it stream out the nozzle, it wasn't streaming out very reliably. It was coming out kind of lumpy.
Lumpy, chunky.
Kind of chunky, lumpy.
Are you sure your temperature was optimal?
Oh, yeah. Well, I did a range of temperatures and nothing changed. I figured, well, let's just print anyway. Came out looking pretty poor.
Pretty sad.
Pretty sad. Yeah, the photographs are up on the Google group. And then I pulled that out and tossed it into the trash. And then I went and I grabbed the Protopasta cardboard spool, and put that on the printer, and that printed optimally. It came out really, really nice. The thread threaded onto the cap very easily. There's some cleanup, a little tiny bit of cleanup in the threads, but the stuff just popped right off. And it did a very, very nice job. An interesting aesthetic, a very matte kind of rough texture to it.
Yeah, it's interesting. It doesn't look at all like any texture I've seen with stainless steel before. I mean, it's not at all what you think of when you think of stainless steel.
Not at all.
But it is an interesting aesthetic. It's interesting that it's slightly heavier, but this feels a lot lighter than the one where it was a total print fail.
But notice the top that was on the glass plate. It's shinier. It's cleaner than regular PLA would be from the glass plate.
Oh, okay.
I mean, it looks almost as though all of the
except the
Aquanet came off
on it,
but it didn't. That's the actual surface of the material. So it's exceptionally shiny, exceptionally smooth, which is interesting. It's very interesting. And that kind of encouraged me. So I went and I got myself some cheapy buffers, attached it to an electric drill because I didn't really have a slow speed grinder anymore. I sold my slow speed grinder a long time ago.
Yeah.
So I figured for this fun project, I'll just use an electric drill. And I put a buffer on it, and I charged the buffer with rubbing compound. And I really worked at it to the point where one of the sides melted. So, I took it to the maximum buff I could possibly do.
Yeah.
And it does have a metallic shine to it under certain light conditions. So it smooths it out a tiny bit, and it does give it a kind of a gunmetal look to it.
Yeah. Well, rather than going right to compound, I would probably start with very fine sandpapers and work just to completely smooth the surface before you. It's tedious.
But it wouldn't have mattered because when I got to the part that melted slightly, the maximum I'm going to get is to the point where the stuff melts.
Right.
And you could see I'm at that maximum on there.
Yeah.
So you can get it so that there's a little patina of a shine, a patina of steel. So it kind of looks like an old steel belt out of an automobile, an old dirty bolt a steel bolt that you took out of an automobile.
But not rusty though.
But stainless steel.
All right, yeah.
Stainless steel is not necessarily polished. It's just not rusty.
Yes.
So from that perspective,
let's mill finish stainless.
Yeah, it kind of looks like it, kind of. But in general, this is a major fail. This is of no value that I could tell, except maybe if I'm doing a model of a gun or an old chunk of metal.
Well, it's the filament that you had that was a complete fail, I think may have had more of the actual metal fill in it because it seemed to be considerably denser.
Oh, yeah.
And that sort of density and heft to a print is an interesting thing because that's not something you usually get out of a plastic part. So
that's true.
But the problem with metal infused 3D printing filament is that we think, oh well, it's metal, so it'll be stronger, but it actually makes it weaker.
It's the exact opposite,
right? Because you have this matrix of the plastic, which you're then interrupting with these tiny little metal balls that aren't really bonded to the plastic as well as the plastic would have bonded to itself if they had not been there.
Right.
You get some density, you get some interesting aesthetic, look to it, but you don't get a stronger part with the metal fills.
Right. Now, this PLA is different from the process that's used by Desktop Metal and Mark Forge, where they sinter it, where they cook the plastic
Burn
out,
the plastic
and
out of it, and then sinter the steel part.
With an autoclave. This is completely different, and this is also different from there's a company out there, from what I understand, that sells you filament that can be sintered out. You print it and send it to them, and they do it for you.
BASF does that.
Yeah, this is different. This is just for an aesthetic to it. And I would say from that perspective, it's probably not worth your time. So save your money for something else. we're going to talk about nozzles. Now, nozzles are, that's the part of the hot end that's usually brass, but not always. And the filament melts and gets shoved through that little tiny hole in the nozzle.
Right.
Your nozzle is a very critical component of your 3D printer system. It's also, what would you call it? Disposable, consumable.
Yeah.
And you have to think of it that way because they wear out. And if you print using a fiber inclusion in your filament, it's going to wear out really fast if it's made of brass.
And anything that's, the slightest bit abrasive, brass is quite soft material.
Yeah. Your nozzle is probably the most likely critical point of failure in your 3D printer. Why? Because that's where all the action happens. And all it takes is, say, your object that you're printing lifting up off the bed, pressing up against the nozzle to shove unmelted plastic back into the nozzle, which will then clog your nozzle, and then you are no longer printing.
Sure. And as soon as you have anything that disrupts the flow of plastic out of the nozzle, like being too close to the build plate or being too close to the previous layer or whatever, if you kind of, stop the nozzle up with something, then you can't push the material into it anymore, and you end up grinding the material. And so there's all kinds of things that go wrong. But the nozzle is the critical point because it's the smallest and the most precise part on the printer.
Right. So. And the nozzle, the design of that nozzle is a good argument for going with an extrusion system that includes your thermal barrier, your hot block, your heater, your temperature sensor, the way it's driven and pushed through the feeding mechanism.
Yep.
The nozzle design is the reason why it's a good idea to not use an extrusion system which is very specific and only made by one company. Or only, how do I say it? That's not the right term. Closed source made by that 3D printing company.
Well, as we've talked about before, there's different approaches. If there's a closed source system made by one company that works well and you can afford it, then it might make sense for your application.
That's a big if.
Right.
That's a big if. Because usually companies, some examples include Ultimaker and MakerBot, where it's a specific design made by them for their printers. Right. Nothing else will work on those printers except their designs, and only they make them, and they ain't cheap.
Sure.
You got to buy the whole thing. You can't just buy the nozzle.
Right. But assuming that it works reliably, then maybe that's a good solution for some people.
Some people.
Yeah.
Now, let's talk about the other side. So if you buy a nozzle, a good example would be the Mark 7, 8, 9 design nozzle that came from MakerBot. That'll work on tons of 3D printers, like the Crealities, I think, are that design. The Race 3Ds were that design. I don't know if I are anymore.
Most of the inexpensive Chinese printers were for a long time.
Yeah. So the Mark 7, 8, 9 design nozzle will work in tons of different 3D printers. The other one that's a good standard is the E3D V6 nozzle design. There are other E3D nozzles, but the one for the V6 seems to be a standard that goes to lots of different 3D printers. Now, why it's really good to have that kind of nozzle is that you can get them super cheap.
Sure.
So the other day, I'm on my tool changer, and I'm printing the Prima Vice that I think we'll be using as a thing of the week or have used. So you guys will be hearing about it. And I like to print the different colors in the different extruders. This way it's all loaded up, and I print one at a time, and I put them on the bed in a way so that they don't interfere with each other. And it's like having 3 printers printing at one time. And I noticed one of my extruders was not printing very well, and stuff wasn't coming out the right velocity, and so it had to be the nozzle. So it was time to buy new nozzles. I didn't have any any new nozzle sitting around. And a lot of folks would say, well, you just take the nozzle out and cook it, and get the stuff that's in there out and clean it all out.
Yeah, that works. We've talked about that in the past.
But because of what I was able to do, I didn't bother. And this works for both the V6 nozzles and the Mark 7, 8, 9 nozzles. You can buy them super cheap. So I went on Amazon. I found a pack of 20 for $8.99. Got it the next day.
Now, I wouldn't bother trying to clean them at that price.
Yeah. Now, people out there will probably say, yeah, but they're not as good. Sorry about that. They're not as good as the original E3D nozzles.
Well, some of them may be better. Some of them could be worse. It depends on who machined them and what tolerances they kept.
So my experience, and I've done this 3 times now, where I bought a bag of nozzles. No, 4 times. I've done it 4 times. The first time we did it, which was years ago, I think we talked about it on this show. They were for the Mark 8 on my replicators.
And you got them off of Ollie.
Got them off of Ollie, and they were not to spec. Like the tips were flattened, and that's not correct. Because when the tips are flattened, they smear the filament, and some filaments, some of these polymers may stick to that flat surface on the tip of the nozzle and create a kind of distorted smear on the surface of the extrusion. So those were no good. But when they were, I bought another batch, which I saw were to spec, and those worked brilliantly. I used them on my replicators. I bought another bag that were the same thread design, but the cone shape was slightly different, and they fit perfectly on the Raise 3D. So I got a bag of them for the reps. I got a bag of them for the Raise 3D, and then I bought a bag of them for the V6s on the tool changer. Now, when you buy these nozzles, people will argue, and I've seen these in the reviews of these nozzles online. They'll say, "Yeah, I got them, but there were shavings still in there." And even when you buy them from E3D, you should be inspecting them for tiny shavings that may be inside. You should be doing that anyway. And a friend of ours once told us that the ideal thing to do to any nozzle, even those that cost $40, is to take the nozzle, and if you're wearing jeans, rub the tip of the nozzle on your jeans.
Just to polish it and deburr it.
Deburr that tiny edge on that nozzle. I would do that, but I wouldn't do it a lot. I'd only do it a little bit. And if you've got a USB magnifier, it's a good idea to inspect the nozzle before you install it. Should be installed with your extruder hot, and you don't want to over-tighten it because it can snap. You just want to tighten it to the point where the block will not rotate. Yeah,
more likely to break your stainless steel cold break tube than to break the nozzle. But at least that's been my experience.
Yeah, but if you break the nozzle, you can just take it right out and put another one in because you've got a bag of 20 of them. So it makes sense. Now, in the end, I don't see that big of a difference in quality. They work perfectly fine. If they don't, you pull it out and put another one in there. So is it worth doing? Yeah, definitely, especially if you're printing a lot.
Yeah. And I would say if you can get them from Amazon and somebody is stocking them stateside, chances are they've done some research on which factory to get them from, because there's all kinds of people manufacturing them in China. If you go to AliExpress, it's kind of a crapshoot. You never know what you're going to get, and what it takes for you to send it back to AliExpress is, a sufficiently high barrier that you're probably just going to throw it in the garbage.
Yeah, but you're not talking about, a couple $100. You're talking about less than $10.
Well, sure. But my point is that by the time it gets to Amazon, that seller knows that if their product isn't pretty good, they're going to be taking returns on it, and that's going to be costing them money. So they're going to make sure that...
That's my dog having a dream in the background.
We've got a dog having a nightmare or a good dream. I can't tell.
She's dreaming. Yeah, she's
chasing bunnies in her sleep.
Talking in her sleep. Anyway, so cheap nozzles. Yeah, it's worth the gamble. I do it. I probably recommend. I would say if you don't want to spend a lot of money on nozzles, you could do it. Now, on the other hand, if you're printing, say, a filament that has a matte fiber in it, or carbon fiber, or a metal powder in it,
Yeah.
No, I don't go with brass at all. You spend the money, go to Micro Swiss or Performance and buy a stainless steel polished nozzle, because these brass nozzles, even the ones that are original equipment, you put that kind of an abrasive filament through it and you'll get maybe one print.
Yeah, it depends on how many of these things you're doing, and I mean if that's going to be a major part of your production or whatever, yeah, definitely go with stainless steel.
Yeah.
But bear in mind that the thermal performance of stainless steel is going to be different than brass, so you're going to have to make some adjustments.
It can be tricky to get them to print as reliably and as well as the brass.
Yeah,
I've learned that on the Rep 2 in the garage. I've got a stainless steel nozzle on there from Performance, and it works well, but it took me a long time to get the right temperatures for those filaments to get it to work well.
But if you just got, a metal filled filament and you want to try, a couple of prints, I wouldn't worry about it.
And if it ruins
particularly because you
if
can
it ruins it, just put a new one.
Put a new nozzle on it, right?
So have you seen the Prima vise? That it's one of the favorites up there on Thingiverse.
Okay.
It's basically a bolt-on vise made of all plastic for like plastic parts. Comes in really handy. It's good for like a helper when you're soldering.
Okay.
So I thought this would be a fun thing to print on the tool changer. This way I can print the different parts in different colors simultaneously just for fun. So I go on my E3D tool changer. I load up a couple of parts and I start printing away. And so I've got one coming out in white, one coming out in black, and one coming out in red. And I'm doing this in NGen. I have a couple spools of NGen left over, which is a formulation that's based on PET.
Okay.
And one of the parts has something wrong with it. Do you see it?
Well, it has an interesting kind of surface texture to it.
Yeah.
Like
that surface texture is something wrong with
partially clogged nozzle.
Right.
Okay.
So actually, what you're holding is the result of swapping out for a new nozzle. It was way worse than that.
Okay, yeah. It looks like either a funky filament or something wrong with your nozzle or something wrong with your temp.
So I start troubleshooting. And, my gut's saying this has to do with the hot end, the extrusion system.
Okay.
And the extrusion system is the V6 hot end from E3D with a V6, standard V6 0.4 millimeter nozzle. And I'm using the Zesty Nimble version 2 as the feeding device.
Okay.
And for those who don't know anything about the Zesty Nimbles, we have talked about them on this show many times. They use what's called a drive cable, similar to a speedometer cable. It's a cable that's wound in a tight pattern that goes through a shield in a Bowden style, but instead of going in and out, it rotates.
Right.
And that rotation is the transferring of the power into a worm gear, which is in the nimble itself. The worm gear then drives another gear, which drives the hobbed gear that drives the filament.
Right. So it's a way of getting the weight of the stepper motor off of your moving hot end.
Yes.
So you can have all the advantages of a Bowden extruder, except you're not pushing the filament down this long Bowden tube.
Right.
You're pushing the filament from the top of the hot end. So it's basically the advantages of a direct drive with none of the disadvantages is the idea.
That's the idea. And for those of you who've been listening to the show for a long time, you would recall that it was working brilliantly. I got it was super light. I think it was 1/10 the weight of the E3D Hemera direct drive system. And I was getting direct drive performance. I could print TPU at PLA speeds without any issue at all.
Nice.
I was able to get really good tight seams between two colors because I was able to get really good control, command authorization on the actual filament coming out of the hot end, which is what you want for real precise printing.
Right.
Well, that's no longer working.
Well, something's going wrong.
Something's going wrong. So I go in there and I start taking things apart. And first thing I do is I lube, because you're supposed to lube their gears on a regular basis. Yeah. So I'm thinking, oh, wow, maybe they're catching. So without trying anything, I just open everything, lube it up carefully, even lube the drive cable, put it all back together, and actually made it worse.
Wow.
Yeah. So now I'm looking carefully at the Nimble.
Yeah, I wonder why that would make it worse.
Now, this is a Nimble version 2, right? So I took the drive cable out, and I took the drive cable out of its neighbor tool. So I have the two Nimbles next to each other, and I put a tool into the square hole that's in the worm gear that the drive cable actually rotates.
Yep.
And it's rough. As if something's wrong, like there's something in there in the way of the gears. Well, I know there isn't. I just took it apart. And I turned the other one that's good, and it's nice and smooth.
So are these 3D printed worms, or is this?
No,
they
are
molded?
They're injection molded. I'm pretty sure they're nylon, or they could be some other material, but they're this white, very durable plastic.
So
it's good stuff. Yeah, it's really good stuff. And the body of the Nimble is printed by SLS, so it's nylon.
Yeah. No, it's a good quality product, but it seems like something's worn out, or it's got something stuck in it.
Well, the word you just used, 2 words, quality product. I don't think they apply anymore.
No, that's too bad.
No, because what you look for in components for your 3D printing system is reliability, maintainability, and durability.
Right.
Okay, so.
You think you've worn it out?
Yeah.
Was this in a position? So if this is in your tool changer, was this in the one of the 4 slots that gets used the most?
No. They all get used equally.
Okay.
And they don't even get used that much. So there's no excuse here. Okay. But let me tell you exactly what I discovered. Okay. So this is version 2 of the Nimble.
Yep.
Version 2, there's 2 halves, and the 2 halves come together, and the worm gear sits between the 2 halves. So they come together onto the bearings of the worm gear, which means each side of the body presses a bearing into the worm gear's hub. So it's like a sandwich with the worm gear perpendicular to the sandwich and the bearings holding it in place.
All right.
And the bolts go the same direction as the worm gear. And what happened is the nylon of the body gave under the pressure of the bolts.
So were the bolts over torqued? I mean, is there a standard?
No, I went out of my way not to over torque them, because I know from the version 1, which had a similar problem, that as you get tighter and tighter, it distorts this nylon body and impedes the motion. It takes things out of tolerance. So what's happening, I found out, so I loosen all the bolts, put the tool into the worm gear and rotate it nice and smooth. Slowly tighten the bolt so that the 2 halves come together, just come together.
Yep.
This starts to get rough.
Okay.
So it's compressed and is now no longer within
tolerance. Yeah, that's too bad.
And what's happening is the halves of the body of the Nimble are from a perpendicular direction, pulling on the sleeves of the bearing, perpendicular to the way of the bearing, binding the bearings.
Okay, yeah.
That's a design failure.
Yeah, you could get away with that provided that the bolts were torqued just perfectly, and it seems like in 3 out of 4 on your situation that worked.
I don't agree with you. I don't agree with you.
Okay,
because nylon moves, so even if they're torqued just perfectly it
does under any kind of a strain.
Any kind of strain, even if it's a specific amount of torque over time, the nylon's going to give a little, and you'll and it's going to be all loose.
Go out of spec,
right? So it's a design fail because they didn't take that into account.
Yeah.
So the story continues. I found the problem. I'm thinking, so let me go back to my other. I have 3 of these V2s.
Okay.
One of these other V2s is making a ticking sound. And sure enough, it's the same problem. And now it's not the only design fail that's on these
Right.
nimbles. There's another design fail that's pretty upsetting. The drive cable, and we've talked about this on the show.
The top.
Yeah, the top
breaks
cap.
off.
Yeah.
Yeah.
The top cap that holds the drive cable into the nimble body is held in place with little tiny tabs
Right.
that rotate in and lock.
Yeah.
What were they thinking?
Right.
That thing's moving around and that cable's being pulled side to side, and eventually those tabs are going to break off.
Yep.
And that's what they do.
Yep.
So 2 of them broke off and 1 of them didn't. And I figured, well, let's just leave the one that didn't, and when it does, I'll replace it with my own design that goes on there. Well, this nimble that just went out of tolerance had the original cap on it, so you can't use that as an excuse. Okay, so
Well, that's too bad.
so I contact the Zesty guys in Australia, and it wasn't easy getting to them. It took a while, and I finally get to Brian, who's there at Zesty, and tell him the situation. And he's like, "Well, we're not sure what to do. We could send you new bodies for free." And I'm like, "Yeah, but I have a V3, and the V3, the design's completely different, and that issue's no longer there.
Right.
So if I'm going to replace my V2s with new bodies, I'm just going to get the problem again within a year or so,
Right.
because of the way it's designed." So I said, "No, you should send me the V3s." And he goes, "Well, we can't afford to do that. Maybe we can sell them to you at a discount." So, okay, well, you tell me how much it is. I'm willing to go for cost.
Right.
And
sure.
I don't need new drive cables, so you could take those off. And you tell me how much it is. I paid just under $400 for these 3 Zesty Nimbles. He wanted just under $400 to replace them
Oh, geez.
because of their design fail.
Yeah. Well, that's too bad.
So this is a nimble fail.
Yeah.
Our suggestion that this is a good product is now nullified, rescinded.
Yeah.
I would warn folks about this product.
Now, does that apply to the V3? So you're saying the V4 is improved?
No, I don't know about the V. There is no V4.
There's no V4.
The V3 is a completely different body design. They call it the flex, so that you could put the angle that the drive cable goes into the body in different ways.
Right.
However, they ignored my input and they put the drive cable cap back the way it was on
okay.
V3.
Yeah.
So if you buy the V3, this compression problem will be gone, but the drive cable cap is still a problem. And because of its design, I can't think of any way to get around it with a different cap.
Sure.
There's no way to bolt a cap onto it.
Right.
So I'd have to say,
That's too bad.
No, stay away.
Yeah. Well, I hope they can get all the bugs worked out of it, because it seems like it's a great idea. It's just the execution of it is, obviously a challenge, especially doing it with 3D printed parts and requiring that kind of tolerance and that kind of tolerance to remain over time in a part that's under all these different strains is.
Yeah. But let's face it, guys, there's more than just getting it to work.
Right.
You've got to get it to work and get it to work in a way that it could do it for printing every day for years.
Sure.
And if you can't do that, you don't have a product. It's that simple.
You don't. I mean, it needs to last as long as any other element of your printer.
Right.
And,
well, to some degree. I mean, the hot end, you've got things like the nozzles.
Yeah.
But this particular part, which is a critical part, should have been way more durable.
We don't think of the extruder. We think of hot end nozzles as consumables, and maybe hot end liners, and maybe heater elements and thermistors or whatever. You could argue that those are consumables, but the drive system, that's not consumable. You don't replace those.
Not a consumable. Not at all.
So
now I got the hint that these guys knew they had a design problem, which is why they went to V3. And the emails going back and forth.
Yeah.
It was there were comments made by Brian that kind of hinted, they knew about it, and there's nothing, they can't afford to fix them. They cannot afford to send replacement V3s for all the V2s that they sold.
Sure.
Which means, you probably don't want to buy from these guys.
Yeah.
Probably not a good idea.
That's too bad. I'm sorry to hear that.
Yeah. But there is some good news here. There is some good news. The good news is now we have an opportunity to explore other ways of driving the E3D tool changer hot ends. And so in the weeks and months ahead, we'll be testing a ton of new driving extruder drivers that are out there that have come to the market since we put these V2s into the tool changer, and we'll be playing with them, starting with the super low cost Orbiter 1.5.
Oh, okay.
Now, I get comments from friends of ours on the forum saying, well, there's problems with the 1.5. You should go 2.0. Maybe, but in the meantime, I had a 1.5 sitting in my tool chest, and it mounted onto the tool changer in minutes. Mm-hmm. And it's just a matter of plugging in the motor and changing some settings, and I'll be printing on that tool again. So we'll be reviewing that next, and maybe we'll take a look at the latest coming out of Bondtech. There's also a different flex drive available out there that costs way less than the Zesty Nimble, called the Flex 3 drive. I think they came out before Zesty. We may take a look at them as well. Mm-hmm. So that's the good news. We get to play with other stuff.
Yeah, well, sounds good.
Oh boy, Whitney, another show written to the hard drive, waiting for encoding, uploading, and commitment on our feed to all of our very supportive listeners. Thank you all out there for your support on Patreon. Thank you for your positive reviews or wherever those are made. And hey, thanks for listening. We do it for you. We do it for fun. And since we do it for fun, we make mistakes. Okay, so we talk about cheap nozzles. And, you know, I did really well with cheap nozzles for the Mark 8.
Yeah.
Which is the old MakerBots.
Sure.
The old Replicator 2. They work great. Cheap nozzles were okay. I used cheap nozzles on the Race 3D, and they work just as good as the Race 3D original nozzles. But when I got to the cheap V6 E3D clones, no. At least the batch that I bought,
right.
The first one I put in, I'm getting all sorts of distortions and effects because it wasn't a well-cleaned nozzle. Inside that orifice, there's some distortion.
Stuff, yeah.
Some kind of distortion.
Yeah.
So I swapped it out, put another one in. Yeah, same thing. The whole batch was no good. So on that segment, I would put in not a full retraction, but a caveat. Buy it from Amazon so you can send them back.
Yeah, sure.
Because you may have to.
Right. Yeah, I mean, you can save a lot of money, but obviously you're giving up something for that savings.
Yeah, you sure are.
So it depends on how many nozzles you go through and whether that's really a worthwhile thing to you or not. So
okay, so we do have a thing of the week, and this week it's my thing of the week.
Yes.
I'm going to call, let's see if I can bring it up here. It's the Allen wrench, what's it called? The Allen key driver handle. And this comes to us by a Thingiverse maker whose handle is Keyboard Printer.
Otherwise known as Ayame.
Doesn't say where he's from.
He or she doesn't say where they're from.
It's an interesting design where you put a standard size, any size hex key, and if it doesn't fit, you can enlarge it into the slot and slides all the way down. And then there's this long bolt that you screw all the way in, and it holds it in place. And now you have a handle. Instead of having to twist that little end, you can grip it with your hand really tight. I wouldn't recommend doing this in PLA, and nylon would be too flexible. So PETG, maybe PC. PC may be too brittle for this. So probably PETG for this. What I like is the screw that holds it all in. It's compressed. It's not laterally tweaked, so it won't break on you. However, I don't think it needs that much thread. I mean, that much thread will be stronger. You will get a better grip.
Yeah, but you're not pushing against the the screw. The screw is just kind of holding the hex key in place.
Yeah, so I'm going to try printing this and see if it works really well. So we'll see how this goes. In any case, it's thing number 5251712. And that's it. If you've got a tip, a question, or a candidate thing of the week, what are you waiting for? Send us an email.
Send it to info@3dprintingtoday.com. That's THREE, the letter D, printingtoday.com.
And again, we invite you to join our forum on Google group. Just go to Google and type in 3D printing tips and tricks. When you get there, hit the join button and give them an email that doesn't have to be your personal email. In fact, I recommend it not be. Get yourself a Gmail account or some other account that's free. Give them that one, but be sure you can get to it because there's going to be some verification that goes back and forth. And that's only if you want to post. You don't have to do anything if you just want to read. Let's see. What's coming up on our show next week, Whitney?
Next week's show number 427. We talk about lightweight extruder feeders.
And then we discuss the Prusa XL posts that we're seeing on Facebook.
And then we question design quality.
I guess that's it.
Great. Thanks for listening.